All right. So on behalf of the European Space Agency Global Development Assistance, I would like to welcome you all to this webinar on Earth observation for environmental social governance schemes. This is one of a series of webinars hosted by Caribou Space and Imperative Space that forms part of the monitoring and evaluation activity of ESA GDA. And Caribou Space published a report in December 2023 on the use of Earth observation for environmental social governance schemes. Today, we'll be discussing this report and some aspects of it, and it'll also be available on the GDA website after this session. Just before we continue, please note that that we're recording this session, and if you have any questions, please add them in the Q&A box. There'll be a chance to address these at the end of the webinar. So we've got a really great selection of panelists here today. We have, from the World Bank, we have Dieter Wang, who's been a great help in actually writing the EO for ESG reports. Representing IFAD, we have two consultants here today, Rakhat, Zhanuzakova, who will go over the technical aspects, and Oliver Mundy, who will cover operations side of things. We also have Christoph Albrecht in the background. He's a little bit ill today, but he's the program coordinator of the GDA program, as well as Alex Chunet, who represents ESA at the World Bank, both of which will be here to answer any questions you may have. I myself, from Caribou Space, will be hosting this webinar. And before we hear from our panelists, Alex will give us a bit of an introduction to ESA and the Global Development Assistance. Thank you, Alex.
Thanks, Carlotta. So I'm gonna quickly share my screen. Perfect. Let me know if you can see it. All good. Great. Thanks a lot, everyone. So indeed, I wanted to give you a very quick overview of the Global Development Assistance Program in order to give you first this contextual information, and then, of course, we'll transition to the ESG-related topics. So essentially, the Global Development Assistance Program is a European Space Agency program that is being supported by 14 participating states of the European Space Agency, which you can see here. And this program comes after around more than 10 years, actually, of collaboration between the European Space Agency and international financial institutions, such as development banks. This 10 years, more than 10 years collaboration went through several phases. There was first EO World, which was really about small-scale demonstrations of your services to raise awareness. Then there was EO4SD, which was more about consolidating requirements. And now, since 2020, there is the Global Development Assistance Program, which is more about actually mainstreaming Earth observation. So those different programs and the different phases have allowed us to go through those 5 A's, moving from availability and accessibility to awareness, pushing to acceptance, and of course then adoption. And this has really been the objective of this long-term collaboration, to achieve the adoption and the long-term adoption of Earth observation technologies. This is being implemented through different thematic activities, which you can see here, going from disaster to transport infrastructure, which was just kicked off a few days ago. And of course, that includes agriculture, clean energy, and all the other sectors that you can see here on this slide. I think what's also fundamental about the Global Development Assistance Program is really the coordinated and complementary approach that we've been implementing and that we've deployed. Essentially, this consists in the European Space Agency taking care of the knowledge development through the GDA aid activities and the other cross-cutting activities, which you can see on the green wheel. So essentially developing value-added products and services based on Earth observation, but then having this tied and complemented with activities from international financial institutions, which you can see in the blue wheel, and mainly activities related to capacity building, skills transfer, in order to ensure the scale-up and long-term adoption of those technologies within the institution itself, so within the development bank, but more importantly, within the countries that receive the financing and the lending from those institutions. So essentially ensuring the adoption of these technologies within developing countries. This essentially results in this potential curve that you see here, and that's essentially one of our objectives, which is uptake. We want to ensure the wider uptake of those technologies, and what you see here essentially is the proportion of World Bank project documents that mention Earth observation. The curve has been increasing exponentially, in a sense, from 2% in 2010 to around 12-13% today. And this overlaps very well with the different phases, programmatic phases that have been deployed by ESA and the European Space Agency. So we do not, of course, pretend that ESA is the only contributing factor to this trend, but we've certainly been accompanying it, and we will keep working to ensure this uptake. And once again, we do not want uptake of Earth observation for its own sake, but we want uptake of Earth observation because it will increase the efficiency and impact of development finance. So that's the global picture I wanted to give here. Thanks a lot to everyone, and very excited to be part of this webinar. Thank you.
That's great, Alex. We will now be hearing from Dieter Wang next. Dieter, don't know if you could turn your camera on, that would be ideal. Great. Thank you.
Certainly. So pleasure to be here. Thank you for the invitation. And it's great to always work together with ESA and the GDA and now with Caribou Space and Imperative Space. This is growing, and we have our take on ESG and how it combines together with the geospatial aspects. I prepared a few slides, not too much, but perhaps I can show these quickly so we can get an idea. I'd like to give you the more economic and the financial angle that we're working on. Oh, I can't see this yet. And so share. There we go. So screen one. That looks good. So you can see it. Great. I'll take no for it. Yes. So this is now everything I present to you is what we do at the long-term finance team, which is part of the finance competitiveness innovation global practice. And we've been working a lot these days on two aspects. One is what we call sovereign ESG, which is different from what you see in the press, which is predominantly about corporate ESG. So let me go to the next slide. We have several years, I think 2019, 2018, we launched the first version, and earlier last year, we launched a new version of the sovereign ESG data portal. This is the place where we bring all the relevant data in here. This is primarily development data, and we want to add more and more geospatial data into this for various reasons. It's for gap filling, it's for bringing data more up to date. It's also to allow people to look closer into what we are looking at, we're covering, because as it stands now, this database, let me show you, is being used by many asset managers, index providers, rating agencies, because we provide a lot of the development data that is necessary to characterize these developments. Now, we do our best to bring this up to date, but as mentioned, it's not ideal. It's many gaps here and there. But more importantly, what we're definitely missing is helping people to ideally go from a country level data set to a subnational municipal data at district level, admin 1, admin 2, even if we go to admin 3, wherever available, that will be a huge leap forward. Right now, everything fits into an Excel sheet. So as you can imagine, this is to make it easier accessible, but also it's limited to the country level. Also, it's limited to the annual frequency, which I'll show in a second, we can improve upon greatly. So a few words, I don't want to spend too much time on this, but what we are working with, we see a lot of possibilities, a lot of promise, and where I and my team were working very intensively on these so-called sustainability-linked financing frameworks, in short, SLBs. the reasoning is, the purpose is to bring in more quality, but also to leverage our public financing from the development banks or international organizations to bring in more private capital from financial markets. But what we caution is these things have to happen in a good quality, that we don't have greenwashing issues, we don't have accusations of just calling it green, but not really doing that. So we operate on a country level, and so far 3 countries have come out with a framework. Maybe you heard about the SOB, the Sustainability-Linked Bond from Uruguay and Chile, and recently Senegal also announced one. And these are mobilizing billions of US dollars in terms of financing towards sustainable goals. We have a background paper on this, happy to share this afterwards and how we think about that. But let's get into a little bit of the technicalities of where all this Earth observation data goes into. This SOB is a financial instrument, which very basically you use to mobilize money, and at some point you repay it. But in the meantime, you need to pay interest rates, like in a mortgage. And the interesting part here is that, different from conventional bonds, if you have a target, for example, deforestation, emissions reduction, or anything else that, social indicators as well, but let's think about deforestation. If you manage to reduce deforestation to a degree as you suggested, your interest rates will go down. As a country, that means that could be millions or hundreds of millions of saved interest rates. But if you fail, this might lead to a penalty and you have to pay more, meaning taxpayer money will be used to repay a debt that became more expensive because you didn't manage to reach the goal. A very simple structure, but it ensures that it's in the issuer's best interest to reach these targets. And as a background for those that are more familiar with green bonds or blue bonds, this is a different approach. It's complementary and it's very well suited for large transformative projects. I will show you an example for deforestation. So yeah, we're not starting from zero. There's plenty already out there, and especially Latin America has been extremely innovative. So our partners, the IDB and the other development agencies, were working very closely with them. Now let's look at deforestation and where geospatial data comes in. We are a team and a bunch of economists, so we first of all think about what drives deforestation on a macro level, on a country level. So forest loss is something that's maybe driven by commodity prices or exchange rates, right? If it becomes more profitable to export timber products or beef, well, people will then, of course, start to deforest more. But also weather conditions or outlier events, pandemic, will influence that. And all of that is for us necessary to understand how much deforestation we would expect and how much is more or less than expected. Because that's what we can tie, or ideally you could tie a financing instrument to have the carrots and sticks aligned given a specific benchmark. And long story short, you could come up with something like this, and on a country level, you will be able to see, in this case, Brazil's deforestation going up and down, but also giving context in terms of how much we expect and whether or not we have more or less deforestation. So this is a very quick tour about this, and this is the economic story, right? This is something we are very passionate about, we've written papers about. But this is just one step in a direction, and there are different ways to look at these benchmarks. And if you do a good job, you're able to make projections which seem to go quite well in what we are recently observing. But let's come into the interesting part, namely the Earth observation part. Deforestation is something that we can look from the macroeconomic perspective, but we can also look at this simply, in this case, through the clouds. Because the very same decomposition we can also do exposed by simply looking at what happened. So we're not interested in just one number going up and down, and that is total primary forest loss or how much net gain, net loss. but we are actually very much interested in this particular pixel. If forests were gone, what did it become into, or what did it turn into? And that is where the land cover LUCF data comes in. Because the story I could tell you before is why it happens from a country level. But the other question is, where did it happen? And can we find whether this is really because of agriculture, because of pastoral land? These all will give us much more information to set performance targets, to reward a country for saying you can prevent deforestation because of cattle raising, or you can, it's hard to fight deforestation because it's about urban expansion. So we would like to see something like this, where we can disentangle a change in forests, so on the aggregate level. But we'd also like to see this transition matrix. What became what? And at each point in time, you can imagine a slice of these matrices changing, and you can see, all right, in the last couple of years, it was predominantly a cropland-driven, cropland conversion-driven dynamics, whereas later on, perhaps, these are just small seasonal variations that you shouldn't relate to an instrument. And the fantastic work we've been doing with ESA and the GMV is that we were able to bridge a bottleneck by looking through the clouds, which purely looking at optical data on the left-hand side, we would have problems. But due to the synthetic aperture radar, we can look through the clouds and thereby build better data sets. So I'll show you two case studies, but let me summarize here already my main thoughts about why we need this data from our perspective. So the higher frequency, the higher resolution, the commonality across reporting agencies. I'd like to just note here, if we look at, for example, Latin America, and we'd like to compare performance between Colombia, Peru, Brazil, but then it would be great to have an objective source that we can all kind of look into and take it from there, rather than relying on individual ministries, which might have different reporting lags or different standards. So that's a big game that could help with monitoring and reporting and verification. And yeah, of course, we can much better understand when it happened at a specific point in time, rather than relying on synthetic pictures that might not reflect a particular period. So let me show you in the last couple of minutes a demonstration of how this might look like, and may do a new share. So I hope you can see this new picture. Great. So this is very much, I should maybe put this in dark red as under development. This is maybe the 5th iteration now that we have been on a journey together with ESA and GMV to really get from the high-level data into these transition matrices. So what you see here is a nice visual representation of how these transitions happen. Essentially, these are the matrices I showed you before. And what's very nice is that we can see where, how much land is left and where it comes from. And just based on looking at this without any further analysis, you're able to see roughly when more forest outflow happened, when more forest inflow happened, like regrowth, afforestation. And what's also very interesting, you can see here until 2016, we only had we had more data, but this is what we can be confident about on semi-annual data. But since then, with Sentinel-2, we can have quarterly data, which increases our training sample, increases our coverage. And I think that's highly, highly desirable. Now, the last thing I'd like to show you is something we've done in Brazil together with a local think tank with EPAM. And with them, we built this forest at risk dashboard. And here we are combining the two approaches, where we are taking the country level macroeconomic data, so exchange rates, commodity prices, etc., and try to tell where would that happen, what's at risk. because only if you know what is actually exposed of deforestation can you next year say, well, did we prevent it or not? So here you can see, for example, different probabilities. We have protected areas, indigenous areas, conservation areas, and that of course helps you to maybe look into particular regions, see what's the likelihood, where is it most likely to go. And without geospatial data, this is absolutely impossible. And we're very keen to explore this further on, mostly from the aspect of monitoring and evaluating projects, and ideally tying these to financing. So I think I'm roughly out of time. Let me stop here. And if you have any questions, happy to take them now or after the presentation of colleagues from IFAD.
Great, thank you, Dieter. Yeah, if you do have any questions, add them into the chat box and we'll respond to them at the very end. But thank you for that overview on EO for ESG at the World Bank. That was great. We'll now hear from Oliver and Rakhat, who will be giving the IFAD perspective on this topic.
So thank you, Carlotta. Before I start, can you hear me? Excellent, thank you. So my name is Oliver. I'm here together with my colleague Rakhat. We work for the International Fund for Agricultural Development, or in short, IFAD. We have three parts in our presentation. We're going to give you a short introduction, then present you some examples, case studies, and then have some thoughts on a way forward.
Hello, my name is Rakhat Zhanuzakova. I am GIS and remote sensing consultant. I have more than 13 years experience in land use change, natural resource management, assessment, and cartography. And I support the environment, climate, gender, and social inclusion division, and also research impact assessment division in analyzing GIS data at IFAD.
And my name is Oliver Mundy. I'm trying to make IFAD geospatial. I authored a catalog of GIS tools and applications in IFAD, and I co-wrote a manual how to map investments. I do a lot of coordination, knowledge management partnerships, and Rakhat is the person she's the true expert, and she does all the data crunching, data download, and so on.
International Fund for Agricultural Development is an international financial institution specialized in United Nations agency based in Rome, and IFAD funding more than 250 projects in more 150 countries with low interest loans and grants for project designing to improving income and productivity, build resilience to the impact of climate change, improve food and nutrition security, and empower women, youth, indigenous people, and persons with disabilities.
So basically, IFAD's mandate is to finance rural development projects, and we mainly work with ministries of agriculture. This means what many people misunderstand: we do not implement anything. Basically, we provide the financial resources to governments in order to do rural development projects. We've been thinking a lot about GIS and EO applications in IFAD operations, and we've identified 9 areas that can be aligned to different stages of our project cycle. Maybe the most important ones, in our opinion, that we spend most of our time on is the first one: geographic targeting and vulnerability assessments. So we want to use GIS and Earth observation data in order to understand where are the most vulnerable areas, which are the areas that need the most support, and this is what we call geographic targeting. And then the other 2 areas where Rakhat and I work a lot is basically E and F. This is basically M&E and georeferencing procurement of works, and we're going to present that to you today.
Yeah, first question. Why use GIS Earth observation in our funding operation? For better project targeting, for better supervision, better monitoring and evaluation, reporting, auditing, better assessment, adaptation, natural resource management, biodiversity, better reputation, attracting more funding, more innovation, and advanced analytics.
So Rakhat explained why we should. So everything will improve. That's our main message. If you use GIS and Earth observation, specifically, this technology or this approach can be plugged in or can enhance many of our operations. So, for example, many of the targets of our projects are spatial. So let's say hectares of area developed, or roads, kilometers of road, or number of infrastructure developed. So these indicators have all a spatial dimension, and that's why we say they should be mapped. Then once per year, at least once per year, we visit a project. And so if you have a project area map or the project investment maps, this really helps us understand the project. Banks also do a lot on safeguard compliance. So we want to safeguards are basically principles a project should adhere to avoid negative environmental and social impacts, and geospatial can also help there. Then also our auditors have used geospatial procurement as well, and then for many types of assessments as well, especially impact assessments and environmental assessments. So we're going to now present you, now this is some theory we've given you, and now we want to present you 5 examples of how GIS and Earth observation is applied. And if you have questions, we can give you more applications, or we can also explain further how these were done.
In one of the applications, the project Rural Socio-Economic Opportunities Program, POSER, aims to improve the living conditions of rural poor and increasing their resilience toward the effect of climate change. Within this project, 12 different types of infrastructure established. Water-related infrastructure includes water system, water points, pumping station, and reservoir. Farm buildings included piggers, cattle pens, greenhouse, and chicken pens. Also, the project financed around 500 micro-project income generating activities and mapped around 250 hectares of land placed under climate resilience practice. And all the layers of the project published on the website using GeoServer, open source server for sharing geospatial data. This web GIS is publicly accessible, and you can select layer, zoom in, and explore the location where the project operated. The quality, if you see, geotagging of investment location is very high.
Thanks, Rakhat, for this example. Another example is we're currently doing together with the European Space Agency, also together with the Global Development Assistance Program of the agency, an assessment of the environmental impacts of a project in Turkey. Here we specifically asked for to measure the extent and come up with possible indicators to measure the impacts of terracing. You can see here, down here, you can see a hill that has been vulnerable to erosion, and the project introduced like terracing and afforestation there. So now with the help of the Global Development Assistance Program, they've mapped all the areas that the project intervened on. And just one more picture here. You can see here how it looks like before and after. So you can see all these stripes with now and the little trees planted there. The trees are growing very slowly. And this also shows in the Earth observation-based indicators. So for example, vegetation cover, bare soil, and soil moisture we have here. And we see a change, luckily a positive change of these 3 indicators. So we want to understand more how to use these indicators, and we also want to use observation to verify the true extent of certain activities.
And next example is a coastal climate resilient infrastructure project in Bangladesh for improving markets by installing raised areas and drainage system to prevent flooding. and also comparison households around treatment and control markets. To see therefore more climate resilience, comparing groups and areas process for impact assessment, compare a sample of project beneficiary. It's called treatment group. With similar groups, individuals not exposed to project interventions, it's called control group. By comparing of two groups, it's possible to assess changes that are attributable to the project. And also selecting the right control group, it's essential. Yeah.
Here's another example. This is actually my favorite, one of my favorite case studies that we did. It's a bit old now, but I think it's still very valid. This project in Sierra Leone was financed by IFAD and GAFSP. It's called the Smallholder Communalization Program. One of the interventions they did, they introduced low-cost irrigation schemes in valleys and introduced a new rice variety. Farmers were able to grow things 3 times per year instead of once, and they could have more income. So you went to the field and you could see, oh, they have nicer houses now, and they were having more income. Farmers told us that they've shifted, they changed the way they farm. So, but if you look at this circle down here, these dark green areas, that's where they mainly do slash and burn practices in order to clear the land. And many farmers now shifted from these higher areas down to the valleys where they cultivate rice in these new schemes. And so what we did, luckily the project mapped all the schemes, and they also mapped a few ones that they did in a screening exercise. So we had a perfect treatment and control group. I think it was like 150 schemes each. So we compared the 150 schemes that weren't developed with the ones that were developed. And then we literally just how do you say? Oh, we got data from firms, which is a data set from NASA where that recorded fires. And then we literally just did buffers around the schemes and just counted the number of fires before and after the project. And so we saw that there were 60% less fires in the developed areas compared to the undeveloped schemes. Basically, which is like an indirect indicator that farmers did shift their practices from environmentally harmful slash and burn practices to the new schemes.
And the next project is a project for rural income through experts. Supported coffee producers in Rwanda from 11 to 20. And this project supported coffee producers. Over 2,800 households associated with coffee cooperative is surveyed as a part of impact assessment. And as a result of impact assessment, have a rainfall impact yield, 35 lower yield, but project farmers were affected less by 8%. Heavy rain, not drought, it's main climate problem for coffee producers.
Thanks, Rakhat. So just some thoughts on the way forward. You've seen a couple of examples of how IFAD applied Earth observation technology. Maybe with the last example, once a household is georeferenced, what their impact assessments do is basically to extract the climate history of that location for the last 30 years, and that flows as an additional variable into the econometric models of the impact assessment. So basically, GIS is used to identify treatment control areas, and then once the household surveys are georeferenced, they extract the landscape history or the climate history for each of the households, and that flows in as additional variables. And then they move away from GIS and they do their regular economic analysis. And that's how they can basically find out these things that Rakhat just presented. If you ask us about the challenges, I think we will go more into detail in the discussion. But from a technical perspective, one of the major challenges is that a lot of things are not mapped that we finance. If things are not mapped, that means we cannot see if change happened. Many of our colleagues assume, oh, we can just use Earth observation to detect these things. No, you have to map something, and then you can take EO-based indicators to see what happened there. With regards to another challenge that we see is that many GIS and Earth observation experts, they are not familiar with the development world, and vice versa, of course. They speak different languages. Our job is to bring both together, and that's sometimes not easy. So our development experts, they don't understand basically some very simple, for us, simple differences. And also with the EO experts, sometimes they think, oh, this indicator will solve all the problems, but they don't think about how can it be plugged into operations. Another one that we face is to come up with good hypotheses for Earth observation, to use Earth observation indicators. So it depends on the type of investment, but they can be very different. We assume like, oh, if you improve productivity, we will have a higher vegetation response. It will be a higher NDVI, for example. This might not always be the case. So it will be good to formulate concrete hypotheses. What is the intervention about? How could we detect what changes do we expect, and which variable will we take to measure it? Let's say in Kyrgyzstan, where Rakhat comes from, or in Lesotho, there are these shrubby weeds. It's an invasive species. So if we remove them, that would actually reduce the vegetation cover. So you would have a decrease in your indicator. So what we're saying is we really have to understand what's happening on the fields in order to monitor it from space.
And international financial institutions need to integrate the GIS Earth observation operation guidelines and have a dedicated GIS unit, provide support operation, develop system to manage and sharing visualization, GIS data, also Earth observation data, increasing data, GIS literacy of their own staff and projects, and also build partnership for advanced analyzing, for example, European Space Agency.
Just to come on the last point, IFAD is not like the World Bank. We're not a data organization, so we really rely on partners in order to bring in new data sets, new types of analyses, and so on. Please read our guidelines for GIS-supported M&E. You'll find maybe some useful things in there, requirements, standards, terms of reference. We have it available in English and French. Maybe some other useful resources that we have is we published a catalog on tools and applications for that's maybe worth reading. We can also recommend there's a new manual from KfW on remote management, monitoring, and verification. So that's a great source. So please read it. And then another thing that our colleagues from WFP, the World Food Programme, they're really leading things in certain aspects. So they've introduced 2 Earth observation-based indicators in their corporate reporting system. So that's really worth exploring if you wish to systematize the use of Earth observation in your frameworks. That's all from our side. We're happy to discuss with you now.
That's great. Thank you so much, Oliver and Rakhat, for that overview of IFAD and the work you've been going through. We already have some questions here. The first 2 are for Dieter, and then we've got one for you. So I think we can start with this one. This is an anonymous attendee who asks if the findings of the pilots that you shared earlier with national governments are those public? Can people access them, and if so, where? This person's particularly interested in the Brazil case as it would support policy making in reforestation. Dieter.
Yes, thank you for this question. It's of course everything we do, we'd like to bring to policy to inform policy making, of course, our lending operations, but also as a global public good so that people can use it. And everything we've shared, I mean, it was a bit fast in my presentation. Everything, but the dashboard at the end is already public. The dashboard should come on somewhere next month. And the point is, for example, the idea of predicting deforestation, we have discussed and shared with the Brazilian Treasury, for example. keep them up to date. The data I showed previously was also with from Brazil, but also with other Latin American countries. So yes, we do want to share them with the national governments. A bit of a struggle on our side is to make things visible. We're not very good at that. That's where I think these kind of operations and reports really help. But yeah, if there are concrete questions, happy to take them or share these reports afterwards.
That's great. Thank you, Dieter. And just to follow up on that one, someone's asking about the method you use to produce the land use change and forestry in one of the pilots that you showed earlier. Is that something you would be sharing in these pilots?
Absolutely, yeah. So Elizabeth, right? Yeah. Thanks, Elizabeth, for the question. I think these are two questions, if I understand correctly. So the model used for the macroeconomic part, we specified that in the paper. It's called Good Sustainability Bonds Help Prevent Deforestation in the Amazon. Quite a mouthful. And somewhere in the appendix, the model is written down, but also the main part. That is a simple linear model that uses machine learning, lasso regularization to identify the most generalizable macroeconomic exogenous drivers. But for the LUCF question, that what I've shown there, that was for Peru. That was the first pilot country we looked at together with GMB and ESA. And it was quite interesting because what the technology we looked into at first and the one we used at the end are very different. And it led to some innovation, also hopefully a scientific paper. The method that they used was continuous change detection, where you're trying to filter out the underlying states and to understand what the transitions are rather than trying to classify each point in time. And it's very scalable. I'm very surprised in a positive way that we can also apply this in other areas. The important caveat from what we've seen is it needs to be tailored to every single place. And of course, we need to write training data, validation data. So what works in Peru is maybe a good starting point for Indonesia, but of course we have to tailor this to local contexts.
Maybe just to add very quickly on this, to what Dieter was mentioning, as he mentioned, it's a method called continuous change detection and classification, which was developed around 10 years ago, a bit more than that. And that's, as Dieter mentioned, analyzes harmonics. So essentially, the trend over time, over minimum 6 months up to a year of the signal over the pixels and the area. And then it classifies it depending on how it evolves and how the trend evolves along the time, basically, through the year to classify it and give certain classification. It allows you to have very accurate results because certain type of land use or land cover will have certain behaviors such as agricultural land or forestry, certain type of forestry during the year. One of the caveats, as mentioned also, is that you need to wait those 6 months or potentially a year to have the full 100% accurate results, right? Because it's indeed based on the harmonics and therefore this trend through time. So that's something to take into account when you implement those technologies.
That's great. Thank you, Alex. So we've got a question I think that Oliver might be best suited to answer. This question's also someone anonymously posted, and it's: how have country governments reacted to you using EO in their countries to track your projects? How do you develop relationships with them in this process, and how do you engage with them, especially in more secure, conscious countries?
Thanks for the question. It's a good question. Maybe quite interestingly, most of so we did an inventory a few years back. We basically asked our projects like, oh, what data do you have on your projects? What geospatial data do you have on your investments, on your activities? And most of them had something. So we collected data from over 60 projects, and we didn't really, we had to follow up sometimes, but we got a lot of data. They were all willingly happy to share this data with us. And so I think in this case, our projects are already mapping a lot of their things. It's not very coordinated. Some projects are doing very well. Some are absolutely horrible. So the data structure is awful. But basically, they're already doing it in many cases. So the question is like, how can we help them to do it better? And then one thing that none of the projects were doing was more advanced analysis. So they were doing like simple spatial calculations, simple mapping, and so on. But then, like in terms of impact assessment, there was that we don't have many examples. So we want to help them to assess their own impacts as well. Some countries so basically most of the countries are already doing it, most of the projects, and then of course there's some countries where it's difficult. You're not allowed to have a GPS in some countries or map things, otherwise you have a security concern, and that's the response.
That's great, thank you, Oliver. And here's a question that sort of addresses one of the barriers you and Rakhat mentioned earlier, about having these two worlds meet together. Someone asked, what type of presentation is most suitable at the local or field level when you're giving this kind of information? Is that open source GIS, website, paper maps suitable for mobile devices, or else? Are you aware of any challenges there? Maybe Rakhat can answer this one.
Thank you for question. I think all methods are very suitable for the field collection data, GIS data, and nowadays GIS mobile application, I think it's more suitable. And of course, it's necessary to take into account the availability of internet for data collection, also the amount of data. Also, now we very testing of open source GIS mobile collection application, and we already tested QGIS, QField, and yeah, it depends on which data you will collect. Thank you.
Great, thank you so much. We also have a question from Emmanuel Mondon. Thank you for your question. This one's about ESG, I think, in general. There are a lot of frameworks to use and report at the sort of national, European, and international level. And there's more and more corporate and impact investment funds. Do you think, this one's for you, Alex, if you don't mind answering it, do you think a common and worldwide framework is needed and that could avoid duplication, ensure that all parties are aligned and streamlined in terms of the reporting and comparison?
Yeah, so indeed, I mean, I think it's very much needed, and that's what standards such as the SEA that has been developed by the UN with the support of other organizations seeks to do. It's really pushing in this direction. I think essentially when it comes to implementation and practical implementation of this kind of technologies, it comes back to the fact that there is so much need, there is such a need for tailoring and calibration at regional and local level that sometimes we have this kind of clash between this global approach and global framework, and then what can be implemented and will be accurate locally, nationally, or regionally. I mean, at least that's what we're facing in our engagements with World Bank. But this type of standards you mentioned, we are exactly working down this line, potentially with some actors such as the IMF, together actually with the World Bank. So I think we're not necessarily there yet, but that's something we keep striving to and pushing forward. So really, by combining both the localized part and those global frameworks, I think essentially we'll get closer to it progressively, but not there yet.
Okay, thank you, Alex. We've got another question for Oliver, going back to the bridging the two worlds of GIS and EO and development. What do you see as an approach there of trying to bridge those worlds? Because this person sees that as one of the main obstacles in more EO adoption. And I'd like to just take a step further and ask you, how can we, as a big advice there, how can we go from the theoretical value of EO to its practical use and really move that trajectory?
Oh, good question. I agree. It's a major challenge. Maybe first of all, you need people who know the projects and know the countries well, and can formulate what I call hypotheses for EO-based indicators. So you have to know what the project is doing and then how to measure whatever it is. So that would help. And then for certain types of investment, you could do it. But then we're at this stage where I can't even answer simple questions, so to be honest. So basically, when you go to the project and you say, okay, this project will do a change in cropping patterns, we can maybe find indicators to find that. Or we have a reduction, let's say a de-shrubbing in Lesotho. Maybe we have a reduction of the vegetation index. Or it could be a land use change, right? So, we're now converting this. We're now doing agroforestry. We're growing rubber trees in Sri Lanka. So then we have a land use change. Or we have we introduce irrigation, and then the cropping patterns change. So it's like it has to be a little bit tailored. We didn't come up with that yet, because there's no doubt that we can use it, but so far we don't have these solutions there available. And sometimes, yeah, it's a bit, yeah. And then there was also a second question. What I think what should be done? Should I answer that as well? I see nodding.
Yeah, go.
I think that M&E and might find strange that procurement is absolutely essential. So a lot of our investments are quite large, and if they're big, they have to go through a process called they have to go through procurement. So it's basically the procurement of services or works, and specifically of works have to go through procurement. That means we're having a new system. It's called Open. So if a project wants to procure a dam or an irrigation scheme or a road, and it goes a certain threshold, I don't know, $50,000 or more on, then we could plug in georeferencing standards there. So like, if you want to do an irrigation scheme, we want to have the water source mapped, we want to have the canals and the pipes mapped, and we want to have the command area. So basically the to-be irrigated area, want them mapped. We want it at the beginning of the project to see, and then at the end. And then once we have the data, then we can look, do we have now more water use or less water use? We have more soil moisture or a second cropping pattern or a change of crops or stuff like that. So I hope that at least that's our approach now. Procurement, it sounds strange, but that's I think the way we can to go.
That's great, Oliver. Thank you. And Alex, just to follow on from that and trying to move away from these barriers, where do you see the role of the Global Development Assistance Partnership in furthering the agenda of Earth observation for ESG?
I mean, essentially, we are collaborating with all those institutions to improve and to elaborate value-added products and services that they can use to better understand their environmental and social impacts. I think a challenge that was highlighted by Oliver in his presentation that's very important to emphasize is to have the geolocation of interventions and projects. We cannot forget that the institutions who are dealing with our financial institutions, they are not the ones that are implementing the projects, and therefore they rely on their counterparts most of the time to geolocate the project itself or the interventions. And this takes itself some training and capacity building. And as we work with the GDA and through the GDA with those institutions, we need to liaise closely with the other teams that potentially train and facilitate the geolocation. So just to name one, there's the GEMS team at World Bank that we work closely with, because those guys essentially train counterparts in countries to use tools that allow them to kind of monitor interventions and projects by geolocating them. And without doing this, we will not be able to use Earth observation, and therefore then to bring in the GDA to create some value-added data products or services that will allow to better understand the environmental and social impact. So that's something I guess I wanted to highlight.
Great, thank you, Alex. We've got one final question to answer, and I think Dieter, you might be most suitable for it, but again, please feel free to jump in, the rest of you. And this one's on the future prospects in the context of Earth observation and AI and machine learning, and in the development finance context. And Arif is asking, how are we close to be able to utilize foundational geospatial multi-models anytime soon? Are we close to that? With GBTs, we pass the threshold and suddenly everything is accelerated. Do you think investing in more classical Earth observation GIS infrastructure makes sense, or should we wait? I hope that wasn't too long of a question. All right, great.
Thanks, Arif. Very interesting question. Let's put it this way, we are also looking into what we can learn from large language models. The World Bank is probably not very known to be on top of the newest editions of the machine learning world. But nonetheless, we do have applications of such models within the bank and also for the knowledge services. But perhaps a point that is also a challenge we see, well, first of all, I think the method, it's not really about the technology we need to use to extract the signals. Of course, there's innovation needed there too, but for example, our purposes, we need very, very basic things to get the insights to act upon. And there's also not just saying that we don't want to go further than that. I think we do have the capacity, but for our needs, understanding like very basic land transition data, that we don't need any additional machine learning than the ones that we already know. For example, the ones that we mentioned, Alex has already said that is more than maybe 10 years old. These things for us are useful, and also these are established methods and easier to understand. And for the newer ones, there's nothing to say we can do this on top of these things. Perhaps that's what you mentioned with the multi-model approach. But yeah, I think for perhaps other people, maybe our colleagues at IFAD have complementary view of this, so they're also very open to see. But I think in our case, if we think about financing instruments, the straightforward, the more established, the more transparent the methodology, the more you will gain by that.
Great, thank you, Dieter. Does anyone else want to add to that?
I can only agree. I think what we're lacking is a basic collection of GIS data from our projects. Once we have that, then we can use AI and machine learning and so on. So that will be. So right now that we can't tap into that because we don't know exactly where the investments are. That means we cannot attribute any changes of whatever indicator to a specific location. So that's the thing that limits us. Once we have it, I know that, for example, Jeff, the Global Environment Facility, they make it now. They have to send all the data there to them. So they're collecting our database on this. So everybody who has a Jeff project, be careful what you submit to the Jeff, because machine learning and AI, they will be able to analyze it in future. So it should be correct.
Great. Well, thank you so much. I think the webinar is coming towards an end now. I'd just like to thank the panelists, for also anyone who was able to join and watch the workshop today, as well as Sarah and Elena from Imperative Space, who are in the background helping run the session. Big thank you to you. We will be uploading the recording to the GDA website, and we'll be sending the link to anyone who registered. And feel free to have a look at the GDA website in the meantime and see some of the other work that everyone's been doing. Thank you and goodbye.
Thanks, everyone.
Mm-hmm.